Python script that we use to scan Wi-Fi access points within a apartment complex. We wrote it specifically so that we could walk the Pi car around the complex and be able to scan about every 10 seconds looking for new Wi-Fi access points. And that gave us the ability to write a file with a list of all the Wi-Fi access points. So what we did is we are using the OS module and opening a subprocess, and the subprocess simply executes IW list, passes in the interface, scan, and then grep for ESSID, and then sort that uniquely. Create that list and then append a timestamp to it, delay for 10 seconds, and then decrement the value so that eventually this procedure stops. So we do write these JSON files. As you can see here, I have quite a few of them already from walking the neighborhood, and they are they're giving you the so you can see we've got timestamp, and then we have a list of all of the SSIDs that are seen, which can then be used to further understand the networks available in the neighborhood and take additional forensic action based upon what you find. So next step will be to add GPS to this. As you can see, we've got a timestamp, we've got the SSIDs, and then if you had GPS, exact GPS location, then you would be able to create quite a database of Wi-Fi access points. Now this is very limited information because that's all we wanted to save, but we've enabled the Linux firewall on the Raspberry Pi, and we specifically put in a deny rule for 8080. So we've got it specifically set as denied so that we can visually see that it is deny. So we have a server listening, a Flask API server listening in port 8080. We tried to make a request, simple GET request to that endpoint, and we see that we have a failure here to connect. So the failure to connect is because the firewall is blocking. So if we enable the firewall, so if we do an explicit allow, so we'll just change this to allow, and it will allow traffic from the entire /24. And status is updated to allow, so we'll try that request again. And we see that we did get a response. You see that it did go through. So, the traffic is now allowed. Is of a packet capture being performed using tcpdump. And for the demonstration, I have the front end and back end from lab 2, which I'm just using to send data and capture the packets from the virtual machine in VMware to the Raspberry Pi car. So the Pi car is listening on port 8080 with the Flask API, and the Electron.js front end is on the virtual machine. And so we're crossing layer 2 boundary, and we are going to go ahead and perform a tcpdump. And we're going to do that on all interfaces because I have both a physical network cable plugged into the Pi car, and also I have Wi-Fi as well, which is, so I've got two interfaces currently connected to the network. So as you see here, I'm going to just start seeing some messages. So hello, hi, and then we'll just do some simple numbers so we know when it was sent. Okay, so we've got a few packets, and we're going to go ahead and stop this packet capture now. And we've been able to capture some packets here. And so now we've got a PCAP, which you see here. So it was just written, right? And I have opened the Python REPL, and I've got a library called Wireshark, which is a library that wraps tshark. And so I'm going to go ahead and load that PCAP that I just created. So now I've got it up here loaded. So you can see cap and what we can do. So let me go ahead and print cap sub 0. And so there's our packet that we just captured. So as you see, we've got the MAC address, so here, destination, and we've got source, and it's IPv4, and we have all of the information. So layer IP includes, the header length is 20 bytes, and we have the protocol, the time, so the protocol TCP, we've got the source and destination for the IP layer, and we've got the port, so the source port 34616, and the destination port is 8080, and we've got some additional information down here, including the TCP flags, the window size value. Instead of using tcpdump, we're using the Wireshark on the Raspberry Pi so that you have a nice GUI to be able to create a PCAP and also analyze the network flows as they come in, and through the live capture. And filter, what I'm doing here is I'm filtering by TCP port 8080, which is what I'm listening to on the Raspberry Pi. And I'm going from my other machine here, I am going to send some requests to generate a lot of network traffic. So simply from the request module in Python, and then I'm going to send 100 requests over to this API endpoint. So as you can see, those requests are coming through, and we're listening on the wire, and due to that, we can see all that traffic. So we can open up the packet here, 7885, which was captured on our wireless interface, and we can drill down into all of the layers here. So we can see the frame and all the information, the MAC address you can see here. So there's the source, IPv4, so all the TCP information, flags, so source port 8080, and down to HTTP, there's the 200 response, and that's why Wireshark is very